So hi everyone, in this video we are going to understand a one more algorithm on load balancing. So in the last two previous video we have seen two algorithms, round robin and the weighted round robin. Those two algorithms were static algorithm. Now we are going to understand one more, that is a least connection algorithm. Now this is a one more algorithm to distribute the request among the servers. So the two algorithms that we have earlier discussed were static algorithm, which basically means that they did not consider the computational power of the system. They follow the predefined rules. But in case of a least connection algorithm, it is a dynamic algorithm. Why a dynamic algorithm? Because in this algorithm, if we are using a multiple server like a horizontal scaling, so we have a multiple servers. So in that case, for multiple servers, this least connection T keep tracks of the active servers. So I think you did not understand. So let's deep dive into this. So let's say we have a client. We have a client, and let's say we are using a load balancer. Load balancer and using server 1, server 2, server 3. So this is the basic architecture. If you are aware of single server architecture, I have also created a video on that. So let's say we have a client and a load balancer we are using to distribute the request among the servers because we have multiple servers. So we first have to configure least connection algorithm. Now what it is? So it is a basically a dynamic algorithm, not a static one. It is a dynamic algorithm. Why a dynamic algorithm? You'll get an answer within a few minutes. Just wait for a minute. Okay. So in this algorithm, let's say we are using three servers. We have one load balancer and it is supposed to distribute the request among these three servers. So the server itself keep track of the active connections. Active connection. Now what I mean by active connection? Active connection basically means the number of requests on each server which is not finished yet. It is in the process of uh, resolving. So it is in the process. It is those requests are not resolved yet. Okay. So active connection basically means the number of requests that are still processing on by the server, not completed. The request is not resolved yet. Okay. So let's say on the server, this server has 10 active connection. By active connection I means number of requests. In this server I have 3 active connection, and let's say on this server I have 2 active connections. Okay, so you understood the point that by active connection we mean that the number of requests that are still still in process, not resolved yet. Okay, so these three servers have active connection 10, 3 and 2, right? Now if we are configuring least connection algorithm, so the least connection algorithm will make sure that the incoming request will pass on to that server which has the lesser number of active connection, which basically means which has the less number of request. Okay, so let's say we get a request R3, R1, whatever. Now this request will pass on to that server which has a less active connection, which has a less request. So this request will passes on to the R3. Now R3, it already have 2 active connections which still are in processing mode, and one request came. So now its active connection become 3. Got it? So this is okay. Now why I said that it is a dynamic? So it is dynamic because the server have to keep track of the active connection. It is not static, because in static we are not checking the active connections, right? That server have to monitor every time. No, nothing like that. But in least connection algorithm, server have to monitor and keep track of the active connection properly. so that only this algorithm will able to distribute the request to that server which has the lesser active connections. That's the whole concept of this algorithm. Now you might can think, okay, if this request passes on to the request to the server which has the lesser number of requests, okay, great, but what if all the servers have the same number of requests? Let's say like this servers have same number of requests, 3 active connection, right? Now if we compare these two, this has the lesser number of active connection obviously, and if we compare these two, these are the same number of requests. Now let's say a request came R2. Now on which server this request will pass on? This request will pass on, it will be depend, because now the number of requests is similar. There is no server which has a lesser number of requests. So in that case, when we have a same number of active connection on each server, then we use a round robin technique. That let's say a request came R2, so R2 will pass on to this server and its active connection become 4, and let's say a request pass on to this server and its active connection become 4. And now let's say इसका रिक्वेस्ट वॉज बिन रिजॉल्व, सो अब इसके रिक्वेस्ट कितनी हो गई? लेट्स से 3. सो अब जो नेक्स्ट रिक्वेस्ट विल केम, it will passes on to this server. Okay, so that's how a least connection works, that request will pass on to that server which has a lesser number of requests. So server have to monitor and have to carefully keep track of the each request that are openly and not resolved, that are in a processing phase. Okay, and if the server all the server has the same number of requests, then the request will pass on to based on round robin technique, that the first server get the first request, second server get the second request. Now you might ask that how server keep tracks of these active connection. So server keep track of the active connection by calculating TCP sockets. TCP sockets basically means the connection between a client and a server. So a server keep tracks that how many sockets are currently being created by the client, between the client and the server. So it calculate the TCP sockets, and TCP sockets signify the active connections. Okay, and we have to make sure that that the system or the server properly increase the number of count by 1 and decrease the number of count by 1. Let's say this server has a 10 request, and again a request came, and let's say this is the smallest active connection. Let's say it has the 15 and it has the 16. So this has a less number of requests, less number of active connection. So if a request process, that it will be passes on to this server, and the request will become 11. So we have to the server have to properly increase the number of requests. If it does not work properly, then there is no means of using least connection algorithm, because it is properly distributing the request among the servers, properly making a balance algorithm. And let's say two requests resolved within a minute, so the request should become now, let's say, 13. Okay, so this process has to be done very carefully we have to run the server. So that's why it is dynamic, because we have to keep track of the active connection, we have to monitor our servers, right? If you have understood this point, now it's time to understand one thing, that we also cover the edge case if all the server have the similar request, same number of active connections. Now the thing is ki the number of active connection does not equal to number of load. मतलब कि if a server has a number of, let's say this has a 3 to 5, the least active connection is here 2. Up according to the least connection algorithm, the server which has a lesser number of active connection, the next request will passes on to this server. But least connection algorithm does not keep track of the computational power, because this might happen that this two request has let's say those requests which take a lot of time to process. Let's say someone is downloading a movie, or someone is downloading a file, right? So less request doesn't mean less load. No. So this is a misconception that the less request does not equal to less load. It can happen that the lesser number requests are lesser on that server, but these are take time to process. Okay, so I hope you till now you have understood the concept. So this was the whole concept of least connection algorithm, that properly make sure that the request increased by one and decreased by one. If the simon We have to cover the edge case that if all the server have the same number of requests, in that case uh, we have to define any other algorithm which can distribute the request among the servers. And the load number of like lesser request doesn't mean less load. This can happen that the lesser request have to take more time to process, so the load can be more, but again the request will pass on to that server which have the like can have a more load, right? So I hope you understood this concept. Thank you. Bye bye. Let's meet in the next video.